So A gets replaced, substituted by B. Right? So you get to here. And then there's another rule, different rule. On the left-hand side you have a B. The rule is B arrow hash. Okay? So you substitute B for hash, and there it is. So that whole thing is the derivation of this string using this grammar. Okay? So concept of derivation is important. Now you can draw a derivation like this in the form of a picture, and you know, remember, about half of our brain, our human brain, is concerned with vision. So pictures are very useful because you know, our brain is geared towards analysing pictures and images. So pictures are always good. Okay, so here's like the derivation again. You know, starting from your start state, and here's your final string. They're all terminals. So here's like, you know, in a sense, with time going down, you know, like time going this way, the picture equivalent would be like time going down. So you start with start 8A, and then you replace the A by 0A1. So you've got 0A1, and then the A is that A. So you've got 0A1. Then you replace the middle A by again 0A1. And the A of that one you replace again, third time, so 0A1. Then you replace the A by B, you know, like here. And then the B, you replace the B by hash. Okay? So that derivation, and this, well, it's a tree, it's called a parse tree. So there's another new term you need to memorize, okay? A parse tree. So this is a parse tree. The verb to parse, what does it mean? In ordinary English, it usually means just take an English sentence. Well, you can parse any language. Take a sentence and break it up into its parts, basically. You know, rather crude definition. But that to parse a sentence into, for example, its noun, verb, prepositions, articles, you know, the stuff like that. Okay. So this is an example of a parse tree. In context of a grammar in computer science. Okay? So you start symbol and your final string, consisting all of terminal symbols. Right? Okay, so that's an example of one string that you have derived. This is a derivation. It's a derivation. It's an example of one string that you have derived from the grammar. Okay? Now you can derive an infinite number of strings. So the set of all strings that you can derive from the grammar, by definition, that set is called the language. Right? It's the language of the grammar, meaning it's the language of strings that are derived from the grammar. Okay? So the language is just all strings that your grammar generates. Put it that way. So you know, 2 exclamation marks. You know, really important concept. So you're using the grammar to create the strings. You're making the strings using the grammar. Yeah, that you know, the same bit before. That's the essential idea of this whole chapter, right? So the core idea, so you really get it. Okay? Alright, now the language that is generated by a grammar, or created by the grammar, you write this way. Now you've seen this sort of thing before in the previous chapter, where we had, for example, L of R. And R would be some regular expression. So analogously, now we just write L of G. Now before, when we had L of R, what did that mean? That was the language described by the regular expression. Okay. Well, now we've got the language generated by the grammar. So analogously, L of G. Okay. So you're sort of half familiar with this concept. Right? So you write L of G as the language of the grammar G, or that's shorthand. You could say L of G is the language generated by the grammar G. Okay, sort of more formal definition. Okay, so what is now for this particular case, for this grammar G1? What is that language? You know, all the strings in that language. You make the set of them, and that's what a language is. Remember, a language is just a set of strings. So, for a string to be a member of that set, what property does it have? In other words, what is the language? Describe the language. Well, by experimenting, remember that, and this is sort of like a technical term. Remember, experiment means to, well, in this context, what would it be? I guess you're deriving. See, before, experimenting means you just input the string into an automaton and see if it gets accepted or not. Well, you can't use that here, it's different. So what does experiment actually mean here? Thinking on my feet right now. I guess it means that you try all kinds of different derivations. You get all different kinds of strings that you've derived from the grammar. Okay? So you play, you get lots of different derivations, you get lots of different strings, and you notice a pattern. And here's the set. Like here's your description of the members of your set. In other words, the description of your strings that belong to your language. You can sort of intuitively see, right? So there's going to be, let's say, n zeros. If you have n zeros on the left-hand side with a hash in the middle, okay, and then you have an equal number of ones on the right-hand side. That's all this language does. So this language, L of G1, will be 0 to the n. That just means a string of n zeros, right? Hash 1 to the n. And n can be greater or equal to 0. Why is that? If n is 0, this is the empty string, that's the empty string. So how would you derive that? So you wouldn't have any of these zeros or ones. So what would the derivation be? I guess it would be A goes directly to B, and then B goes to hash. Okay? Right? So that's a description of your language. The language L of G1 is this. Right? Okay. Now here's another very important definition. So if you have a grammar, a context-free grammar. Now perhaps I should mention a bit about this. Sipser doesn't go into it. Well, right, not now. Why this label context-free grammar? Because basically what we've been doing is just talking about grammars. So what's so special about a context-free grammar compared to, say, other grammars? Well, context-free in the sense that when you substitute a variable for the, you substitute that variable, that one variable, by whatever's on the right-hand side of the rule, the substitution rule. Well, that substitution, you're looking, you're like when we replaced A by B, we just replaced one variable by something. And that's typical of context-free grammars, because what we have not done, we haven't bothered looking at what's on the left-hand side of this variable or the right-hand side of this variable. We don't look at the context or the neighborhood, so to speak. Right? We only look at that one variable. So we don't care about the context. So this kind of grammar that does that is called context-free. If you like, you could call it context-independent, or no context grammars, right? Okay, so context-free in the sense that you do not look at the neighbours of the variable that you're substituting. Okay, so that's why they're called context-free grammars. All right, now a language that is generated by a context-free grammar is not surprisingly, labelled a context-free language. Okay, that's also a very important definition. So a CFL, because context-free language is an expression used a lot. So we tend to just shorten it also on the board because I'll use it a lot. We'll just call it a CFL. Okay, context-free language. Here, context-free language. Context-free language. So get used to this. We'll use it even without the dots, the periods, the full stops. We'll just use CFL, a very common abbreviation. Okay. So what is the CFL again? It's a language that gets generated by a context-free grammar. In other words, a CFG. Okay. So a CFL is generated by a CFG. Okay. Another very important definition for you to memorize. Okay, now a few little details. When you're writing out the rules, the substitution rules, if the left, say you have two rules, and the left-hand side variable is the same for those two rules, then you can do the following. You're not going to see it. Be to the next session. Well, I'll do it verbally. I'll give you a really simple example. Now, say you have two rules, and the left-hand side of both of them is the same variable. Let's say A, and the first rule is A arrow B. Okay, and the second rule is A arrow C. Well, you can write those two rules as sort of as one rule, well, one line, in the following way: A arrow B vertical bar C. Okay. Now, when you see that and you look at the bar, interpret that bar as OR. So when you see A arrow B vertical bar C, interpret that to mean it's shorthand for two rules: A arrow B or A arrow C. Okay. So I'm cribbing a little on the beginning of the next session.